section 5.4 is on equilateral and isosceles triangles. So have a theorem for isosceles, and it's called the base angle theorem. And it says if two sides of a triangle are congruent, then the angles opposite them are congruent. So if I know that those two sides are congruent, then the angles opposite them are congruent. So let me get rid of that. Makes it look a little bit confusing. So, okay, it's a pretty useful piece of information actually. And then theorem 5.7 is just the converse of that. So if two angles in a triangle are congruent, then the sides opposite are congruent. So you can go either way basically. If you start with angles, you know the sides. If you start with sides, you know the angles. Okay, so that's, like I said, a pretty useful piece of information. In like solving some of these problems. So okay, and then they're not like theorems, but we've talked about this before. But if a triangle is equilateral, then it's also equiangular. So the other piece is if it's equiangular, what are all the angles? So it's a triangle, so it's 180 degrees. And we can just divide by 3 because they're all the same. So if you know it's equiangular and one of the angles is 60, or excuse me, if it's equiangular, you know all the angles are 60, no matter what. So that's also a pretty useful piece of information in solving like problems. So a lot of your problems today are just going to kind of be identifying like just applying this theorem. Your first like 4 problems Let me see, are you doing odd today? No, you're not. Okay, so the first four problems, it's just if these two sides are congruent, then what angles are congruent, and you're doing the base angles. You know, if this angle and this angle are congruent, then this side and this side are congruent. You know, there's some basic level of, you know, using isosceles and like base angle type stuff problems. So I don't think these ones are super difficult, but let's look at one. I did that wrong. Okay, so when I look at this problem, the first thing I notice is in this triangle on the left, or the top left, all the angles are the same, so therefore all the sides are the same, therefore y equals 4. So it also means that this side equals 4. Then on this other triangle on the bottom right hand corner, I notice that the two angles are the same, so the sides opposite them are the same. So then it also means that the x plus 1 side is going to equal 4 also, because this blue 4 is the one side opposite, so the other one has to be opposite, and x equals 3. Okay, so the problems themselves aren't necessarily like super difficult, but you know, you're going to probably use at some point potentially that all three angles add up to 180. That's possible. And then obviously like the sides are the same, or the on isosceles across from the angles, or the angles are the same across from the sides. So again, they're not, in my opinion anyway, they're not like super difficult. You might need to think on a couple of them, but there's not anything that I think is super tricky. Okay, so no proofs today. We'll come back to proofs in a big way, like next week. So remember, you have a quiz tomorrow, and we'll go over that a little bit more detail on the Zoom. But you'll be able to skip number 8 on the quiz, but I'll go over that again later as well. All right, have a great day, guys. We'll see you tomorrow.